In this video, we'll be finding a confidence interval about the difference of two proportions. Our data tells us that of 200 women asked, 10% believed that we have been visited by aliens, and of 300 men, 60 believed that we have been visited by aliens. Find a 95% confidence interval for the difference in the population proportions, and we'll go in the direction women minus men. Let's define these right away. We have p hat sub 1 equals the sample proportion of the women who believe that aliens have visited us. And then p hat sub 2 equals the sample proportion of the men who believe the same thing. For a confidence interval, we want a point estimate and a margin of error. So we have our point estimate, that's p hat sub 1 minus p hat sub 2. That whole thing is our point estimate. To that, we will say plus or minus some margin of error, and we'll use a formula to find the margin of error. So first, that point estimate, p hat sub 1 minus p hat sub 2 equals 0.10. That's given to us right there, minus, well, 60 over 300. So p hat sub 2 is 60 over 300, and that equals 0.2 or 20%, 0.2. So this point estimate is negative 0.10 because we decided to go in this order, women minus men. All right, that's our point estimate. We will come back to using that. Now the margin of error. The error formula is this critical z value, alpha over 2, times the square root of p hat sub 1 times q hat sub 1 over the sample size of the first one, plus p hat sub 2 times q hat sub 2 over n sub 2, the sample size of the second one. Remember that q is simply the complement of p, so q is 1 minus p. So for the first sample proportion, we have 0.1. That's this 10% of the women, and then q would be 1 minus that, so 1 minus 0.1 is 0.9. Sample size is simply 200. That's given to us. P hat sub 2, we just found that. That's 0.2. And so q hat sub 2 would be 1 minus that, so 0.8. And the sample size for the second one is 300. Working through that formula, we need one more thing. We need this critical z value. Depending on where you get this z value, this critical z value from a table or software, sometimes it's easy and sometimes it makes you, the table makes you work for it. Sometimes the table will just tell you a critical z for a 95% confidence interval is, and then it just tells you 1.96, and that's great. That's what it is. Other times you'll have to look it up. It makes you work a little bit. You'll have to say, well, alpha is 1 minus 0.95, right? Alpha equals 1 minus the confidence level of 0.95, so alpha is 0.05, and so your z, it's really z of 0.05 over 2. If alpha is 0.05, then that is z of 0.025. So that's finding this critical z value that has an area of just 0.025 here, and you would have 0.025 here. So this critical z value, and it turns out to be the same, of course, 1.96. So that's what we'll plug in here, 1.96. So in the end, after all of that, this error is, I'll write it over here, this error is 0.0615. So what you have for your confidence interval is negative 0.10 plus or minus 0.0615, or written another way, you could say it in this interval fashion, negative 0.1615 to negative 0.0385. So interesting there that the entire interval is less than 0, is negative, and that would come up if you were doing a hypothesis test. You'd say, well, it looks like the difference of the true proportions is actually negative, that there is something there, that fewer women, or a lower proportion of women than men, believe that aliens have visited us. So that was a good example of a confidence interval about the difference of two proportions.